Hi guys, tonight we're going to take a look at dilations, and we talked briefly about dilations again in our types of transformations at the beginning of this unit. And if you recall, for most of our classes, we shut off the lights and we looked at our eyes dilate, which means they got either bigger, or the pupil of our eye got bigger when the lights went off, and it got smaller when the lights went on. So we're going to take a look at dilations on the coordinate grid today, and then some properties of dilations. Okay, first we're going to take a look at some vocabulary. And a dilation stretches or shrinks an original figure, and all our figures are going to be on the coordinate grid. So the description of a dilation should include the scale factor, and the scale factor tells us how much we're dilating the figure by. So it should include the scale factor. Keep in mind, factor means multiplication. It also should include the center of the dilation and whether the dilation is an enlargement or a reduction. So the amount by which the image grows or shrinks, that's what the scale factor is. How much are we enlarging it, or how much are we reducing it? And the center of dilation is the fixed point on the plane about which all points are expanded or contracted. So if we have an enlargement of a preimage, if we want to enlarge the preimage, the scale factor has to be bigger than 1. That'll give us an image that is larger. So think of a photocopier. If you want to, increase the size, you do more than 100%. So reduction will have a scale factor that is less than 1, but it has to be bigger than 0. If we have a scale factor of 0, then there goes our image. And if we have a scale factor of 1, we really haven't changed the image at all. If the scale factor is 1, then the preimage and the image are congruent. Other than that, the image and the preimage for dilations are similar. Same size, same shape, different size. So here's the rule we want to look at. If A, and again, here is our preimage, this is our new image, and again, we're talking about scale factor, so it's multiplication. If A is greater than 1, then the dilation is an enlargement. And if A is bigger than 0, then less than 1, then the dilation is a reduction. Doesn't get any simpler than that. So the distance between the center of dilation and any point on the image is equal to the scale factor multiplied by the distance between the dilation center and the corresponding point of the image. So if we're looking at the distance from the center of dilation to B, if this has, I believe, has a scale factor of 3, if this distance here is 3, then this distance has to be, from here to here, has to be 9 if we have a scale factor of 3. So circle the appropriate choice for the following characteristics or properties. A dilation is sometimes, always, or never an isometry. Well, we're going to choose sometimes, because sometimes it's isometry if the scale factor, and I'm going to abbreviate here, is equal to 1. However, it's not likely. We usually don't use a scale factor of 1. Okay, go ahead for number 1, graph and connect the points 2, 2, 3, 4, and 5, 2. So I'm going to do these points in red, the points 2, 2, 3, 4, and 5, 2. So 2, 2 is about there, 3, 4, 5, 2, and 5, 4. And we have this quadrilateral right here. So step number 2, graph the image on the same coordinate plane applying a scale factor of 2. So that means I'm going to take all of these ordered pairs I'm going to multiply them all by 2. So what I end up with is the 0.44, 6, 8, 10, 2, and 10, 8. And I'm going to graph those as well. So 4, 4, 6, 8, 10, 2, no, sorry, that's 10, 4, and then 10, 8, which is up here. And so our scale factor was bigger than 1, so our new image is larger. So let's go ahead and answer some questions over here on number 2. What is the algebraic rule for this transformation? And keep in mind, we talked about this in class on Friday. You have to start out with the coordinates of our pre-image, and the coordinates of our pre-image are just written as x, y. And the coordinates of our image are 2x, 2y. And how the pre-image and the image compare? The sides are twice as long, or you can also say twice as large. Number 3, graph the image with a scale factor of 1/2. So we should be getting a smaller image. So let's go back over to our coordinate grid. So if we graph the image with a scale factor of 1/2, that means all of our points are going to be smaller. So 2, 2 becomes 1, 1. 3, 4 becomes 1.52. 5, 2 becomes 2.51. And 5, 4 becomes 2.5. 2.5 and 2. We're going to go ahead and graph those. Okay, so we graphed 1, 1. So let me just erase those points right there because they're not working. So we are going to graph 1, 1, which is right about there. And then I'll make this a little bigger so I can see it. Then the next one is 1.5 and 2. Then 2.5 and 1. 2.5 and 2. So clearly we got a dilation that was smaller. So let's go over and answer the rest of question number 3. Graph the image on the same coordinate plane. So we need to write our algebraic rule. Keep in mind again, you have to have the coordinates of the pre-image, which are x, y. And in this case, our dilation was 1/2 x and 1/2 y. How did the pre-image and the image compare? They are half as long. And that's pretty much it with dilation so far. So let's go ahead and take a look at the video questions. So just as a reminder, you don't have a copy of these, so this is just something that's on the video. For video question number 1, you need to find the scale factor of the dilation that maps A, B, C, D to A prime, B prime, C prime, and D prime. So what it's asking is, our sides went from 3 to 9 and from 2 to 6. What scale factor would give us an increase from 3 to 9, from 2 to 6? And notice I said increase. And then number 2, write an algebraic rule that would create a dilation by a scale factor of 3. So again, and I'll remind you again and again and again and again and again, when you're writing the algebraic rule, make sure you start out with the coordinates of the pre-image, which are x and y. Be sure to put your answers in on the Google form, and have a good night.